I'll just give you a quick introduction to myself. So my name is Clarissa Gillingham. I've been working with Power Platform now since May 2019. So I'm coming up to my 2-year Power Apps anniversary. And during that time, it's been an absolute whirlwind, because before then, I literally had not heard of anything in the Microsoft stack. I thought that Office was Word, Excel, and PowerPoint, and that was it. I literally started from pretty much nothing. And since then, I've picked up Power Apps, Power Automate, Power BI, a little bit of PVA, and I'm now working as a Power Platform configuration consultant at a Microsoft partner called ANS Group, who are based in Manchester, UK. And I specialize in Canvas Power Apps there, as I did in my previous role at previous Microsoft partner. And I've developed over like 24 different Power Apps solutions, and then some other solutions that were just Power Automate and Power BI for companies across huge variety of sectors, from things like the automotive industry to education, loads of different solutions of different varying levels of complexity. And it's been really a fascinating journey to try and see how you can utilize these tools to really create some applications that don't feel any kind of less than native applications or true, full custom app development. Recently, so when I moved into ANS in the very end of September, I think it was the last working day of September, I was exposed to working solely with Microsoft Dataverse, or I think back then it was Common Data Service, and then quickly changed to Dataverse. And before that, in my previous role, we'd largely been using SharePoint as a data source, and we've been learning about Dataverse. But this was really my first time of making that full-on transition. And honestly, I can say I would not go back now. So this is essentially a lot of my kind of learnings about what I found helped me to actually understand the Dataverse, understand what it could give me as a maker, and also our solutions for the customer, and how really we can make the most of this new tech and really expand upon the possibilities of what we could have done before. So hopefully this will be a little bit of an inspiration, taking you guys along through the journey. I know there are a lot of people who are making that transition or thinking about making that transition, or maybe you're already working in Dataverse and you just want to find out how you can really up your game within Dataverse. So we're just going to be going through first looking at the benefits of changing to a data first mindset, which is a mindset that you really need to have to be able to, as I say, make the most of Dataverse. And then what does that actually mean, and how do we get there? And we'll go through a couple examples of how I kind of like build out these data models in my head, and how can we actually utilize that mindset so that we can go into Power Apps and actually go ahead and use our data models and put everything together into the Dataverse. Obviously, it's always time for change. During the last few months, of course, Common Data Service got rebranded to Microsoft Dataverse. That's a change, and everyone moving. There are loads and loads of businesses moving and making this transition, making this change, and now is kind of a perfect time to go with that, so that you're not kind of, as a developer or as a company, left behind and not taking advantage of this new tech. And as always, making a move in terms of tech or a transition gives us an opportunity to improve things by making changes. So we don't just go and use Dataverse in the exact same way as we would have used something like SharePoint or Microsoft Lists in the past. But just saying we need to change is quite a big statement, quite a big ask for people. So where do we actually start if we want to actually go ahead and start making this change? And ironically, we start at the very beginning. This is a change that we need to make from that very first initial conversation where we start to develop an idea of an application. So let's actually explore what that kind of means. So what we might be used to thinking of is having a solution first mindset. And there's nothing intrinsically wrong with this mindset. It just means that we can't make the most of our Dataverse. So what we would normally do is we'd be faced with a problem, likely a business pain that a customer has, and they'll be describing this problem to us. And the first thing we'll do is we'll ideate a solution. We'll envisage, this is how I could make it look like in Power Apps. This is the kind of input form you might be able to have. And that enthusiasm is fantastic, and that ability to ideate is absolutely brilliant. But what it does lead to is you to build your user interface, build your application with that user experience as the driver. And it's a UI enabled by data. Data is almost a secondary consideration. And this leads to this really pinpoint focus on just a single app. And you end up thinking about, well, what data do I actually need just for my solution? And you don't care about all of the data that affects the company that's outside of your little pocket that you're looking at. And it really becomes all about that one application. Now, as I said, there's nothing intrinsically wrong with this, and it can seem like the right way to go about things, because obviously we want to give our users something that will solve their problems, and we want to focus on their experiences. And that's kind of the point of Canvas apps, is to give that user-driven experience and really allow you to be able to customize the way that users interact with our applications. But there are some limitations. So when we think about things in this way, it can be easy to just stick to one giant table. You just start off saying, well, what data do I need for my solution? And then you just start adding columns upon columns upon columns, and you've just got this one behemoth of a table that then is only really useful for your solution. Or you might end up with multiple instances of similar tables. And while it can be really, really good for just quickly bashing out a tactical solution, if someone says, hey, look, we've got this business critical thing, it needs to be done in 2 weeks' time, potentially this is still the right way to go, because you can do it slightly quicker because you're focusing only on making that one solution and making the data work for that one solution. But it doesn't make the most of your Dataverse. So what will we do to actually make the most of our Dataverse? Well, if we need to get away from thinking about how the data will work for the solution, and instead we start thinking about how the solution will work for the data. So rather than a solution first mindset, we switch to a data first mindset. We get the data sorted first, and then we solution on top of that. So in a data first world, we get given the problem. This is always going to be the starting point. We've got that business pain that we want to solve for our users. And then from that, rather than going straight to thinking, how can we solve this specific problem, we actually need to learn more about the business in total. And we need to learn how we can actually represent all of their data holistically. So rather than having that narrow focus on just that tiny window of information, we're now looking at and thinking about all of their information, all of their data, and the story that builds up, what actually is useful for them based on what data they currently have and store. So from that idea of gaining that knowledge of the entire landscape of their data, we then need to develop a structure that will be able to hold this. And this allows you to this is the part where you're creating a robust data model. From there, we can then think about how can we represent this data? How can we get this data to our users in as easy and efficient a manner for the users? How can we make interacting with this data easy and engaging and intuitive for our users? So now we're thinking, rather than having UI that happens to have some data behind it to make it actually all work and function, we're thinking about data enabled by UI. So we still have that element where we're there thinking about the user experience. It just means that before we jump straight into that moment of thinking, oh, this is what it could look like, we actually first take a little step back and we view the entire picture. And that might change what we actually come up with as our end solution for them, our end idea. It might be very different to that knee-jerk reaction that you first had when they told you their problem. So obviously from that you get UI, which is empowered by data rather than just enabled by it. So this holistic focus allows you to, rather than looking at one particular, in this case, star or a constellation, you're actually looking at the whole thing, a whole lot of space, their whole data verse. And in order to do this, you really need to focus on abstract entities. And we'll kind of see this as we go through the example later on. But by this, I mean, rather than focusing on specifics, you focus on things that are almost blueprints. For instance, if you have a solution that you're building for an automobile manufacturer, rather than focusing on specific makes and models of cars, first we focus on, okay, what's a car? What kind of data do you have about a car? And by doing this, it allows us to really focus on what actually is your data and what objects exist in your dataverse. We need to build up this picture of what elements we can actually use, what elements they have information on, what elements they need information on that potentially they weren't collecting information on before, so that we can strengthen their data model. And finally, once we've got an idea of those objects, we start thinking about what attributes those objects have. And this is where we start to go back into that detail. So why would we do this? Obviously, it's a little bit of a longer process to the solution first mindset. But this means that we can actually start splitting data where it makes sense for the data. So rather than having, say, one solution that touches a certain element, say it touches your list of customers, and then having that all combined in that one giant table, you can have two solutions that are touching the same common list of customers. And that's where the common in the old naming of common data service comes from, in that you can, by abstracting your data away where it makes sense for the data, you can then actually allow yourself to reuse common elements amongst different applications. You can also create relationships between objects. And this is very helpful for instance, for things like the car example. You might have a case of one particular make or model of car all have the same engine. And so you've got an engine object and a car object, and you can relate those together by saying, okay, this engine belongs to this car, or this type of car has this type of engine. And rather than having the car and the engine in the same giant table, you can separate them out. So then you've got this structure to it rather than just having in your head, oh yeah, these two columns are related. You can utilize things like fact and dim tables. So if this is terminology that is new to you, a fact table is essentially a very thin and narrow list. For example, one of the companies that I've worked for, one of the clients that I've worked for in the past was a fire service. They would have had a fact table of all of the different fire stations that existed within their particular service. Now, rather than having this list and then expanding this list so it's one giant table that has all of the possible information that you could have about that fire station, if you keep it thin as a fact table, so you've just got the actual stations, then elsewhere you can have a table of, say, for example, equipment or fire engines, and you can link it, relate it to that particular station that's in your fact table and expand upon that one element of that station. So rather than having this enormous table that has all of the information that could possibly be needed about a single station, you have a thin list of stations and the multiple dim tables, which are called dimension tables, which focus on a particular attribute or like section of information that is relevant to that station, and you can use relations to then link them together. And this allows you to create a data tree that you can then walk through. So you can maybe find out that this person has this piece of equipment that belongs to this station, and you can walk up these different relationships to find all of the information that is related, whether it's directly or indirectly through multiple different leaps. And you can start to see how spaced out they are, how close they are. And this gives you an idea of what data is relevant to other data in your system. So it's really good for actually representing the real landscape of your data, because if you're just faced with, say, one giant table, it's very difficult for users to actually unpick through that and understand, what does this actually mean for our data? What data do we actually have? We just have one enormous jumbled list of things that are of data that's somewhat related to our stations, and that's all we know. If you split it out into those natural elements of where the data wants to split, then you end up creating that realism where you've got data that actually has meaning. You've got all of your breathing apparatus in one place that you can go and look at, and it just makes a hell of a lot more sense, can be focused down to what the user actually wants to get to, rather than just that giant flat sheet. And when you're building this, rather than thinking about just that one solution and trying to get the data to work for that one solution, you're actually trying to create a structure that works for all of the data that that organization has. And that sounds like quite a big and intimidating task, but the benefit of that is that you end up with one database, gives you infinite solutions. You do the work once, and then you can use this data structure that you've built to not only make an application about, say, customer feedback. You could also use the exact same data to make an application focused on quality assurance for whatever product you're making. And all of this would feed back information to the same data structure, and that data structure would empower all of these different ways of surfacing that information to your users. So that might sound a little bit complicated. That's all the theory of why we would do that, but how would we actually go about putting that into practice? Well, always easiest to just imagine a scenario. Let's go through the process for a particular scenario. And if we imagine we want to make a solution for bus travel, probably the first thing that would come to mind is the idea of a kind of interactive bus timetable, because no one likes waiting for buses and not knowing when they're going to turn up. So this is an example of a timetable that existed for, well, that still exists, I think, for a place where I used to live in Poole. And you might be tempted to look at this and think, oh, okay, so we can turn this into a table where we've got all of our stops, sorry, and we've got columns that show all of the times that the bus will appear at all of those different stops. And we might get tempted to just go straight ahead and start making a solution based on this table. But actually what we want to do, instead of going straight ahead and making something that looks somewhat like this, where we've got the different stations in columns and then the different times that the bus will appear going through the rows, instead we need to rein in that enthusiasm, and we need to take a step back and actually plan. First things first, we actually want to forget about the fact that our solution is for bus timetables. We'll come to that later, but we'll ignore it for now. What we want to first think about is the data. So the easiest way, at least for me, to think about this is thinking of it like Lego. So we start off with a blank board and we want to build a scene. There's our blank board. And since our solution is about buses, probably the most logical thing to do would be to put a bus on the board. And there's our lovely London bus. So now the question comes, what is a bus? And that might sound like the most stupid question that you've ever heard. But when we actually break it down, a bus, like any object, has certain attributes. And these are things that a bus has. It has a driver. It has a maximum number of passengers that it can carry. It has a current number of passengers who are actually in the bus already, can have a registration number, an MOT expiry date. It has 4 wheels, a certain engine. There's so much information that makes up what this bus actually is. But it doesn't just have attributes like this, it also has behaviors. And this is what a bus does. So it runs a route and it belongs to a company. And you can see that some of these items here are in bold. And that is because when we think about putting things onto our Lego board, these are also things that we would put onto our board. These are also objects. So we would then consider adding some of those to the scene. So we've got our board, we've got our bus, and we know that the bus drives a route. So let's add a route in. Perfect. Now we've got a road for our bus to drive on. And just as before, we need to ask ourselves the question, what is a route? And a route can be defined by having a first stop, a last stop, and n number of different stops between that first and last. It doesn't actually do anything, about a route doesn't have any behaviors. So just with those attributes, we can describe our bus route. Let's keep going. Let's add some more things to the scene. We know that a route is made up of many stops, and those stops appear in order. So again, we make a stop object, we add it to our scene. And we ask ourselves, what is a stop? So again, it has a location, and a location would then be another object that we would go away and add to our scene. It has an order in the route, or what you could potentially do is you could actually phrase a stop as having a previous stop and a next stop according to different routes. Because a stop can actually be part of many routes. You don't often find, well, especially if you're in a busy town centre, you'll find that a lot of bus stops around you will actually be serviced by multiple different buses, and you always have to check the number. Otherwise, you might end up like one time when I ended up on the wrong bus because I forgot to check the number. Luckily, it was a circular bus, and I got right back to where I started and waited for the correct number. But we've got this relationship here where a stop can be part of many routes. But we can see here that we're starting to actually get into slightly more complicated data structuring. With our attributes on the left, where we're saying, oh, it could have an order in the route, or we could phrase it as having a previous stop and a next stop that it's related to, we're starting to actually ask the big questions. We're making decisions about these things that will impact our application later on down the line before we've even reached starting that application. So we're thinking about solving the problem before we actually reach the problem, which is very helpful for our future selves. So how do we actually turn this ideating of all these different objects that we're thinking about, like pieces of Lego on our board, how do we turn that into something that is useful for development? And we do it through a diagram. Always the way, if something gets complicated, turn to a diagram. And the diagram we're going to use is called an ERD, and this is an entity relationship diagram. And now this nomenclature doesn't quite work out as well as it did before the rebranding for Dataverse, because now entities are called tables. So I guess essentially it would be a table relationship diagram. But the kind of abstract terminology is still ERDs for these diagrams. And these allow you to structure your thoughts and actually start planning things down. It can start to get messy when you're thinking about all these different objects and trying to keep in your head where they actually touch, where they relate, what attributes they all have. So don't try and keep it in your head, put it down on paper. Or in this case, we're going to use a free online tool called erdplus.com, and we'll skip over to that right now. I'll just need to change the screen that I'm sharing. And just while I find that, I'll say, yeah, there's plenty of different tools that you can use in order to get these entity relationship diagrams going. I find ERD Plus is a really good one, and yeah, I'd highly recommend using it. It's free online, and you don't need to worry about losing anything because it's all stored in the cloud. Perfect. Okay, here we are. So this is ERD Plus, and I've just logged into a new account. And you can add some diagrams on the side, add some folders, sorry, on the side. We're just going to add in a diagram. And we're going to call this bus timetables. And let's go in and have a look. So when we get into ERD Plus, we can think of it exactly just like we did with our Lego board. This is our blank board, and we want to add objects onto it. So the first thing we do is add an entity, and we'll just click that in there, and we're going to call it bus. And we can give our bus attributes. So we knew that the bus had a registration number, the bus had a maximum number of passengers, all sorts of these different attributes that you can add in. But the real key power in this is when we actually start to add some other things. We talked about it earlier, how a bus has a driver. So we'll add in our driver entity, and now we can add in a relationship. And we'll just click that in, and now we can use ERD Plus's UI to choose how our relationship works. And I always find that this is easiest done by just thinking about it in terms of sentences. So we'll go from the left first, and we'll say a driver drives a bus. So let's put drives as our relationship name. So it makes sense. A driver drives a bus. Perfect. And we'll start filling that out. So our first entity, entity one, is the first thing that we had in our sentence. So it's a driver drives, and our entity number two is a bus. Excellent. Now we've got this relationship between them. But more than that, what we can actually say is, okay, let's think about how the driver and the bus are related. So a driver could potentially drive many buses. They could be assigned to many different buses, but obviously they're only going to be assigned to one bus at a time, because a driver can't clone themselves and split themselves in between multiple different buses. So we might want to say a driver drives one bus. And then a bus could be driven by many drivers, because hopefully the same driver doesn't need to sit in that bus for 24 hours and do all of the routes that that bus will take. And you can see now we've got these little lines at the end of our relationship line. This means that there's a one relationship at this end, and this means that it's a many relationship on this end. So a driver drives one bus, but a bus can be driven by many drivers. And this is how you read the diagram, and this is how we essentially, the diagram just distills these sentences into a visual format. So what was another entity that we were thinking about adding? I'll put this down here. So we know that a bus runs a route. So we're going to have a route here. And just as before, we're going to put a relationship in. And we're going to call it runs, because a bus runs a route. And we'll go through and fill in that sentence. A bus runs a route. And when we think about how those two relate, we can have a bus can run many different routes, and a route can be run by many different buses. At least hopefully it's run by many different buses, otherwise you'll be waiting a very long time for your bus. Now our next entity that we talked about before was a stop. And let's think about how a stop and a route relate. So we'll put a relationship in there, and we say a route has, or consists of, is probably a good way of writing it, some stops. And again, we say a route can consist of many stops. Put stop there. And a stop, in turn, can also belong to many routes. So we've got a many-to-many relationship here, just as we've got a many-to-many between the route and the bus. And we know that some of the attributes of our stop, we can add in, say, the location. For a route, we can add in, for example, a route number. And what we might want to do is also start to think about, okay, when we're looking at how this route is made up of multiple stops, we want to think about the order of the stops. So we might end up having, for the stop, a last stop and I should say previous stop on there. So this is the stop that the bus would have visited prior to this stop, and this one has a next stop. And we might want to think about potentially how we would then go ahead and think about the time that it might take to go from one stop to the next stop. And actually, when we think about it, what we can end up with is, rather than having those attributes associated with the stop itself, we could make our own custom relationship, which would be able to allow us to do something along the lines of, say, have an order and have a time to next stop. we've actually come up with something that links back to our timetable. Because we've now thought about, well, between our different stops that can make up our route, we have multiple different stops that are in a particular order, and between those stops there is a time that it takes for the bus to get between stop A and stop B. So if we could have in our system what stop A is and what stop B is and how long it will take to get between them, then all we need to do actually to set up a timetable is set off the first stop on the route. So we can say there's a start time for the route, and then we would be able to use this information in the middle to then actually construct that timetable for us. And how awesome would that be? Instead of having to type out in all those different columns all the times that individually this bus will arrive at this stop at this time, and of course the massive headache that would cause if they wanted to make a change to their timetable schedule. If instead you just needed to change the start time, potentially change the order between stops, and potentially change the time between stops if, for example, there's roadworks or a diversion. This allows you to actually dynamically represent the data, and then the solution kind of pops out the other side. By ignoring our timetable and just thinking about our data, we've ended up with a good solution for our timetable. So if we hop back to the presentation 1 second, we can think about how does this actually all relate? Because we've got this wonderful diagram in ERD+, which hopefully looks something like the diagram that I put together here. So good, that does fit in with what we've got in the slide deck. But we want to do this in Dataverse. It's all well and good it being in a diagram, but how do we actually get this into Dataverse? Well, in Dataverse, what we called an entity for our EID diagram is a table. What we called an attribute is a column. When we have a one-to-many relationship, we use a relationship within Dataverse. Same for many-to-manys, that uses a relationship. And if you have a one-to-one, then you can use a lookup column. So let's actually dive back into Dataverse and actually have a look at how we would potentially bring this solution to life. So if I come into one of my development environments, let's create a new solution. And we're going to call this bus management, and we don't call it bus timetable because actually this structure might be able to end up servicing so many different things to do with buses. Say, for example, they would like to have a solution that keeps track of when each different bus in their fleet needs a new MOT. You can use that same bus entity that you created for the bus timetable. So it's more than just a bus timetable. So we'll come in and have a look at bus management, and we'll start off by creating a new table. And we might think, oh, what do we want our new table to be? Let's again come back to our diagram, have a look. Well, our first thing is our bus. That's our central thing here. We can say, create a table of buses. And we'll create that in. And what Power Apps will do under the covers is it will add in all of the standard columns that you need for your table. But the main thing is that you've got a name, your primary name column, and you've also got an ID. And in Dataverse, if you're used to using something like SharePoint, you might be used to having an ID column being explicitly called ID. In Dataverse, the ID column will always have the exact same name as the table itself. And rather than being an integer number, it's what we call a GUID, so unique identifier. So then we might say, okay, brilliant, we've got our identifier and we've got our name, but what actually do we want, what information do we want to hold about our bus? So just as here in ERD Plus, we've got these attributes that come off of the entity, in Dataverse, what we do is we add columns. So we'll come in and we'll say, okay, registration number, that's a good attribute or column to have here. We'll say that that's of type text. Probably we'll make it required so that we can make sure that all of the buses coming in here are being entered into the system are correct, something along those lines. Then we can hit done, and that's our new column. And we can go ahead and just continually do the same thing. So current number of passengers would be hopefully a whole number. Hopefully we don't have any fragments of people. So that can be optional because there might be a case where the bus is actually not in service, so potentially wouldn't need to have a current number of passengers. And that brings us to a question of, why don't we have a field that says whether it's in service or not? And then that can be a yes, no. So by building up these different attributes, you can start to actually flesh out that answer and represent the entity that we were thinking about when we were asking ourselves the question of what is a bus. Now we'll save that down. Let's have a look back at our diagram. What if we want to actually start putting in this relationship here and start putting in our root? You might be tempted to first think, okay, excellent, I know that it's a many-to-many relationship, so I have to represent it in Dataverse as a relationship rather than a lookup, which we would use for a one-to-one. So we happily go straight ahead into our relationships tab here. We go add an entity. We know that it's many-to-many because we've made that sentence and we've run through the logic of, well, if I am a bus, can I run just one route or many routes? Actually, I can run many. And if I'm a route, then am I run by one bus or many buses? I find this is a much easier way of thinking about it and defining that relationship than just looking at here and trying to think, okay, is it a many-to-one or a one-to-many or a many-to-many? And it's easy to get confused when you're just looking at these three and trying to visualize that rather than looking at the diagram. So we'll happily go ahead and say, yes, we want to add a many-to-many and we want to add it to routes. But of course, we haven't actually gone ahead and created routes yet. So just a little gotcha, you can't create a new table while adding in a relationship. So what we need to do instead is go back to our solution and add in a new table, and this table will be our route. Excellent. And in here we could add in multiple different things like the route number and so on and so forth. I won't go through and add a lot because I'm looking at the time and realizing that we are getting to the wire here. So I will just go in and add that relationship, many-to-many, to a route. And one thing that I find really, really useful is renaming this something sensible. Obviously, well, I don't know, maybe someone can make sense of this bus route name here, but what I prefer to do is actually type out that kind of sentence. So we can say a bus runs many routes. And then I also rename that relationship table the same thing, so that when I'm looking back through my relationships, this now makes sense to me as to why these two things are related and what that relationship actually means. Perfect, and then we can save that down. And then what we could end up doing is we could end up creating our forms of our bus and our route, and we could have a subgrid on one of them that would show for example, if it's on the route, it would show these are all the buses that run this particular route. Or if it's on the bus, these are all the routes that this particular bus is eligible to run. And just like that, we've actually started to create a structure and implement it within our Dataverse that will not only enable our bus timetable solution to go ahead and be made and be successful, but will also enable infinite number of solutions in the future and can be expanded upon because we've thought ahead and planned ahead, and we won't end up being in a situation where we've got duplicate columns everywhere. We obviously want to make sure that we've got a single source of truth for all of our data.
Okay, so if nobody else has got any questions, and feel free to interrupt us, then we'll call a close to your session, Clarissa. Oh yes, please do fill in the swag, win some swag.
Everybody loves swag.
Everybody loves swag, they do.